Welcome back. It's time for video 2 from Unit 8, and we're going to take a look at calculations involving annuities due. I've got a PowerPoint we're going to share. It's a fairly short video. You may remember a previous reference point to the fact that the videos kind of have a 15-minute limit, so I went through and looked at the PowerPoint. I tried to figure out logical breaking spots, and I thought, well, pretty good breaking spots, but this is going to be a short video in terms of slides. So let's go get it. And we'll figure out, first of all, by brute force. And then secondly, we'll figure out how's this thing going to go if you use a formula. So I've got a PowerPoint loaded up. The difference between what we're looking at with annuity due and what we looked at in the previous spot with the ordinary annuity is when the payment is made. On annuity due, the payment is made initially at the beginning of a period. So you can think of it this way. Your due interest for that first one, where on that last example on video 1, there was no interest paid for that first contribution to the annuity. On annuity due, there will be interest on that very first payment. So we're going to see the same processes that we saw before. Pay attention to the balances changing as we transfer from one year to the next. So here's our example. We're going to talk about Beth. Beth's got an annuity due. All right, so it's important to read these problems and make sure which kind of annuity we're working with. Again, a 3-year window, 8% compounded once a year. $4,000 is the amount she's going to contribute each year. The difference now is she's putting that $4,000 in right away at the beginning of the year. So as we begin year number 1, here comes her first payment. $4,000, bingo. And what has to happen is Beth's going to want interest on that $4,000 for that first year. So that's the next thing we'll do as we look at what happens for the end of year 1, and we try to represent Beth's balance for her annuity. Well, here comes the calculation of her interest for that first year. $4,000, which was her payment balance, her balance as it reflects on the worth of the annuity at 8% for 1 year, year 1. So she gains interest of $320. So at the end of year 1, her balance contains the $4,000 that she put in at the beginning of the year, plus the $320. So at the end of year 1, her balance is, her annuity is worth $4,320. All right, we're ready to move to year 2. Now hold on, because the very first thing that happens at year 2 is she makes her next payment. All right, so she's going to gain interest on year 2, not just on the $4,320 that transferred over as the value at the end of year 1. Oh no, here comes her payment on year 2 of $4,000, and that's going to change her balance for year 2. It's going to take that $4,320 that we just had on the last slide, and it's going to add the $4,000. That's her payment for year 2. So for year 2, her balance is $8,320, and that's what she earns interest on for the entirety of year 2. So here comes the calculation for her interest on that balance of $8,320. You notice it's $8,320 times 0.08 times 1 for the second of the 3 years, all right? And she earns on that balance interest of $665.80. So let's talk about what happens at the end of year 2 for Beth's balance. Well, it's going to be the $8,320 plus the $665.60. So at the end of year 2, carrying out Beth's balance, $8,985.60. All right, so it was the balance that she had at the beginning of year 2 plus the interest that she accrued for year 2. Moves her over into the beginning of year 3, but now don't lose it here because she's going to make another payment at the start of year 3. So she's going to be owed interest on that. All right, annuity due, so she's due interest on that third payment as well. So there comes her payment. All right, and that was her balance at the end of year 2. So we'll take the $12,985.60 and right away, here comes her payment of $4,000. All right, so she's going to have an interest coming in at 8% on $12,985.60. Okay, or $12,985.60, And here comes our interest calculation for that third year. Wow, nice. $1,038.85. So we've reached the end of year three, which is what we were asked to consider. We've calculated the value of her annuity at the end of 3 years. So we started the year three with a balance at $12,985.60. For that third and final year, she earns interest of $1,038.85. So the value of Beth's annuity at the end of year three is the sum of those two values, $14,024.48. And that wraps the solution for example three. And that is the value of Beth's annuity at the end of year three. Remember, annuity due, payments made at the beginning. So interest is due for that payment for that particular period, unlike what we saw in video one for annuity, for an ordinary annuity. All right. So that wraps example three. You know what? We should have a formula, and we do. And you thought the formula was bad before. So for annuities due, it's even more complex. But the values are pretty much what we met on the formula work from video one. The future value, how much is the annuity worth at the end of its last period? What's its payment amount? What's its interest? What's its interest per compounding period? And same deal we saw before. N here is playing differently than it played in Unit 7. N is going to basically be the number of periods that you're compounding per year times the number of years. All right, and the same aspect for I. I is the interest rate per compounding period. So it's your annual rate divided by the number of times that you're compounding in a year. All right, so we'll look at the use of the formula to calculate, and we won't go back to the previous problem and do it by brute force. It was fun for 3 years. It wouldn't have been fun for 30. All right, here we got Bart. Bart's got an annuity due, 4 years, payment of $5,000 every 3 months. And he's compounding at 8% quarterly. All right, so let's get some values. It's easy for us to see his payment amount. All right, let's take a close look at N and I. His payment amount's $5,000. All right, how about N? Well, it's 4 times a year because of quarterly, and we're playing for 4 years. So 4 times 4 would be 16 compounding periods. The interest rate for each compounding period, since it's 4 times a year quarterly, is the 8% cut by 4, 2% for each compounding period. Plug in line. Very cumbersome to look at. Again, the important success person here is the guy or gal who's good at grouping. So those parenthesis sets are going to be significant for us. So that's a straight plug in. Okay, all I did there was add the 1 and the 0.02 to get to 1.02. That was pretty intense. I think if you're ahead of the game, it's a one-shot go. Right? If you say, I feel better doing bit by bit, you certainly can. You could tear the inside-most guy apart, and you could raise 1.02 to the 16th, then subtract 1, and then divide that by 0.02, and then multiply that number times the 5,000 and take that answer times 1.02. So you certainly can chain it. You can tear it apart if it makes you happier. If you say, I'm going for the gusto, man, I did. All right, in a little while, we'll talk about key sequencing if you want to again. So I got 95,060, and I got about 35 cents. So the good news is by formula, yeah, messy, but it's certainly something we can contend with quite well. Excel, again, a very nice facet for us in terms of calculations. So feel free to run this thing into Excel if you want to make sure that your calculations are looking good. So if you want it, that's why formula. This is annuity due, making sure you're understanding the difference between annuity due as payment at the beginning of the period, whereas ordinary annuity is payment at the end of the period. All right, so at the end of 4 years, Bart's annuity has a worth of $95,060.35. All right. The calculator entry for that last example, again, you've heard me say this before, you can't round until the end. So you've got to use full screen display. And if you get intimidated by that big thing, tear it apart and work it out. You know, take that inside group as you heard me describe and say, I'm going to do 1.02 to the 16th. Cool. Then I'm going to subtract 1. Hit equals to complete that subtraction. then divide that by 0.02 and hit equals again. Then it's simply taking that decimal mess on your calculator times 5,000 and times 1.02. And that ends us for video 2. I'll be back soon for video 3 from unit number 8. See you then.